In this concept, we're going to talk about congruent triangles. There are 4 different methods to prove two triangles are congruent. In the previous concept, we talked about polygons in general, okay? Any sided shapes, any number of sides. Here we're talking about triangles. So the first method for proving congruency between triangles is the side-side-side method, denoted SSS. If the 3 sides of one triangle are congruent to the 3 sides of another triangle, then automatically both triangles are congruent. Okay? Here's an example. Triangle ABC, triangle DEF. If each side is congruent to the corresponding side on the other triangle, if each side of one triangle is congruent to the corresponding side on the other triangle, then both triangles are automatically congruent. Okay? So if segment AB is congruent to segment DC, just like we have here, segment AC is congruent to segment DF, and segment BC is congruent to segment EF, then triangle ABC is congruent to triangle DEF. Let's look at the second method. The second method is for proving congruency between triangles is the side-angle-side method, denoted SAS. Okay. If 2 sides and the included angle of one triangle, when we say included angle, we mean the angle between the 2 sides, right? So if these are the 2 sides, then it's this angle in the middle, right? Are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So here again, as an example, we have sides AB. Side AB is congruent to side DE, side AC is congruent to side DF, and angle A is congruent to angle D. Therefore, both of these triangles are congruent by SAS, side angle side. Okay. The next method, third method, for proving congruency between triangles is the angle side angle method, okay? ASA. If 2 angles and an included side, so when we say an included side of 2 angles, we mean if we take these 2 angles, we take the side between them. Okay, not, this one, for example, or this one. Okay? So if 2 angles and an included side of one triangle are congruent to 2 angles and an included side of another triangle, then the 2 triangles are congruent. Here's an example. So triangle ABC, triangle DEF. Again, angle A congruent to angle D, angle B congruent to angle E, and then this side between the 2 angles here is congruent to the side between the 2 angles here, therefore the triangles are congruent by angle side angle. Okay? And the last method is the angle side method, AAS. So here we have 2 angles and a non-included side. Okay, so we had the 2 angles and an included side, and then 2 angles and a non-included side, meaning it doesn't have to be the side connecting the 2 angles. It doesn't have to be the side between them. So here we have angle A congruent to angle D, angle C is congruent to angle F, side AB congruent to side DE, therefore both triangles are congruent by angle side. Now, one interesting thing to note is that you may have asked yourself, well, what if I had angle, right? So 3 angles equal. Wouldn't this make for 2 congruent triangles? Well, this is a little tricky, but it actually makes sense why this should not be included as a method for proving congruency. So let's say we had these 2 triangles, right? So let's make them look let's make them actually congruent, right? So the angles are the same, but the sides are also the same, right? But let's have something like this, right? So this is one triangle, right? Angle. And this is another triangle with the same angles, right? So this angle, this angle. So this is congruent to this, right? this angle is congruent to this angle, and this angle is congruent to this angle. So the angles are the same, but the triangles are different. They have a different shape, okay, or they have a different size actually. The shape is the same because the angles are the same, but the sizes are different, right? So that's why you see you have to have at least one side in comparing for congruency. That's why angle, angle, angle is not a method for proving congruency. Again, you can't have two triangles having all the angles the same, right? All the pairs of angles congruent, but the triangles in general would not be congruent in this case. Again, because you can have different side lengths. So you have to include at least one side in the comparison for congruency. Okay? So again, the methods that we have are side, 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 side angle, side angle, side angle, and angle, angle, side. Okay, let's look at this example. In the figure above, what is the value of z? So again, we clearly see angle A is congruent to angle D, side AB is congruent to side DE, side AC is congruent to side DF. So this is clearly angle, side angle congruency of the two triangles, right? So both triangles are congruent, therefore angle E is congruent to angle B. So Z, which is the measure of angle E, is equal to 55 degrees. Okay, just like we have here. Okay, and here we have our exercises. Please pause the video, work on these, and come back for the solutions. Okay, so here we want to name the rule that can be used to prove both triangles are congruent. Okay, so we have the different methods that we discussed, or rules. And we want to apply them here for the pairs of triangles that we have. So, in the first example, we have triangle ABC, triangle DEF, right? And we have congruent angles A and D. We have congruent angles C and F, and we have a non-included side AB and DE. So this is clearly angle, angle, side, right? So angle, angle, side. For the second example, we have congruent side here, AB and DE, congruent side here, AC and DF, and an included angle, so this is clearly side, angle, side. Okay. And for this last example here, we have a angle A congruent to angle D, we have angle B congruent to angle E, and we have an included side. So again, this is clearly angle, side, angle. And two angles and an included side. Okay. Alright, and this is it for this concept. See you in the next video.